Good morning, good afternoon, and good evening to all of you from as far as the west coast of United States to Central Europe. I am Clarissa Morawski with the Reloop platform, and today we're going to be hosting a very important webinar about measuring recycling with a close look at what's gone on in Europe over the last few years around the recycling rate calculation. We have with us today Susan Collins, the president of the Container Recycling Institute, and Joe Papineschi, the chairperson of Eunomia Research and Consulting. This is a quick look at the agenda. I will be kind of giving everybody a bit of a background about Europe and what led to the new recycling calculation. Joe is going to spend quite a bit of time doing a deeper dive on the new calculation method from Europe. And Susan Collins is going to be looking at loss rates and the costs of contamination effectively on different materials in the United States. And then finally, going to wrap up with a Q&A. So first of all, a little bit about Reloop, which I think is important. We are an international not-for-profit organization that bring together stakeholders under one common vision, where resources remain resources. We work to accelerate this transition to a circular economy by using research and multi-stakeholder education to drive supportive public policy. And to achieve lasting change, we focus on 5 interrelated areas that form the basis of a circular economy. And these are those 5 areas, program areas effectively for Reloop. And if you'd like to know more about them, our website has a small audio-visual video on these 5 areas that we focus on, and you can get that on the About Us part of the website. Finally, what do? We believe that to shift public policy, we need to connect, inform, and inspire governments, industry, and society on issues related to circular economy. So in this regard, we connect, we share insights and perspectives with people, stakeholders, collaborate on solutions. We inform by using precise and concise evidence-based information to help guide decision makers. And if you go to our website and take a look at some of the content, you'll see it's quite significant. And finally, we inspire. We employ innovative and easy to understand communication tools to get decision makers to clearly understand this important information related to policy. And one final plug about Reloop, we just launched this huge report a couple of weeks ago called What We Waste. It's an analysis of 20 years of growth in the beverage sector, and it takes a look at beverage container wastage across the planet. So please take a look at it. It's on our website. So this topic today really starts with this fundamental question, which is, if you don't know where you are, how can you get to where you're going? And in this way, if we don't have the proper data and measurements and analysis to understand how we're doing related to our goals like targets, we will never be able to get there because we don't have that important foundation and we don't know where we can make improvements and where those inefficiencies in our existing system lie. So with this in mind, Europe understood this. And before I get into what they did, just so you understand how big the European Union is, it's comprised of 27 countries in Europe, and it represents approximately 500 million people. There are effectively 3 branches of government at the EU, a little bit like the United States, where you have the Senate, the Congress, and the executive branch. And in Europe, you have these 3 branches, and the Commission is effectively the executive branch, and they initiate legislation, and there's about 33 ministries there. They're called DGs, Directorates General, and there's one for environment that's responsible for all of the environmental policy that we're going to talk about today. But at the same time, you've got a parliament, which is made up of 750 parliamentarians from all over Europe, different nationalities, languages, and then you have the council, which is only 27 representatives from actual member states. And they really have a huge voice because they're ultimately the countries that have to implement policies, which is called transposition of EU directives into national law. So the reason I put this up was I wanted to describe to you how huge the EU apparatus is. And you can imagine that a piece of legislation that it goes through this apparatus has a lot of checks and ensures that, most of the issues have been dealt with. I would say, you know, if you want to know if the rules for the recycling calculation have been properly vetted, they have been, because they've gone through this enormous process. So what are the targets in Europe? Here is a fairly comprehensive look at all of the waste-related recycling type of targets that come out of EU legislation. And what we're going to be focusing on today is the Packaging and Packaging Waste Directive and the targets that are material-specific targets here. And also, to some extent, I'm going to quickly walk you through these targets that have to do with the Single-Use Plastics Directive, which is a newer piece of legislation. There is the Waste Framework Directive here at the top, which is like the umbrella legislation, let's just say, kind of covering most things, including municipal waste, construction, demolition, and food waste reduction. It also now has the vast majority of all of the definitions for waste policy has been put in the Waste Framework Directive, consolidated in there, which is quite good. So let's continue then. So when we talk about the new harmonized recycling calculation method, effectively it is this, that the calculation of any recycling targets, should be based on the weight of municipal waste which enters the recycling process. And they call that input into final recycling. And if you look at this little drawing here, this is a process. So don't think in terms of facilities, the front door, the back door. Think more in terms of process. For example, a glass recycling process like a furnace, the measurement point is right before the cullet goes into that final recycling process. In the same way, plastics are measured right before they're pelletized or turned into flake. So this assumes that all sorting, even sorting that could have been done at the facility that is the final recycler, all of those sorting losses are not included in the new recycling calculation. And I think it's best illustrated by this photograph of 3 bottles of ketchup. This is Norwegian, just so you know. But you can see on the left, your typical ketchup PET bottle that gets thrown into the recycling system could have as much as this ketchup in there, and it's almost 200 grams in terms of weight. And that bottle will end up being sorted into a bale, shipped to a PET recycler with all of the weight that is in that container. And then as you can see, as we move to the right of the photograph, where the ketchup starts to be removed and eventually washed out completely, the weight drops significantly. And even the washed bottle on the right, it at 52 grams, it still includes the weight of the labels and the glue and even maybe some residual liquid that you could still see in there. So suffice it to say, that difference between the first picture and the second picture is enormous, according to this 274%. Now, I just wanted to talk quickly about our work at the EU level in Brussels when we were working on this project. We immediately went to collaborate with the industry, and we decided that the best industry to collaborate with would be the industry that can tell the story, the recyclers. And the recyclers understood how important this new recycling calculation is, because it shines the light on the losses that occur at their facilities. And they know those losses better than anybody, and they can tell the story better than anybody. And I just wanted to say that they came together as a group in the spirit of better calculation. They are a highly competitive set of industries, because ultimately these are all potentially packaging materials that are competitive. But in the spirit of accuracy, they worked very well together. And just so you get a sense in terms of that competition piece, these are some recycling rates that were put out in a report of Ball Packaging. I believe it was Eunomia that did this study. But you can see on the left-hand bar is the current recycling rates as estimated today in Europe. And on the right-hand side are what they're going to be when we apply the new recycling calculation. So you can see that every material type is going to lose percentage points from their performance in Europe. And in particular, plastics is going to lose a lot. I think it's around 30% in this case. But in spite of this, the recyclers and the material representing the material groups came together and worked very closely with the Commission and also, I believe, Eunomia to ensure that the rules were very accurate and fair. So now we're going to do a quick look at the Single-Use Plastics Directive and this 77 and 90% target. So just to give you a little bit more information on that, this is a target that covers plastic beverage containers up to 3 liters, including caps and lids. And it sets a 90% target by 2029. The rules around setting this target have not been published yet, but at Reloop, we wanted to get a head start, and we hired Eunomia to write this report for us, which is called Getting the Numbers Right. And it is available on our website. And it really focuses on the number of ways in which the fraction may prove problematic. So it looks at the measurement in terms of the denominator and also in terms of the numerator, just so you know what I mean. Here's a perfect example of when we look at the numerator or the denominator, POM is placed on the market. And you can see that the container that is collected from the collection system contains a lot of weight that the original container that was placed on the market did not contain. And that's simply to ensure that if we're going to be measuring labels and ink in the numerator, then we have to make sure that we measure it in the denominator. Similarly, we do focus on the denominator, and the report shows you very clearly that there's 3 ways in which the denominator is underestimated typically. And these 3 ways, I won't get into detail, are clearly articulated in this report. And of course, when you add up the 3 ways that underestimates are reported in, you actually do get a final denominator that could be very, very underestimated. So this report sheds a bit of light on that, and it gives some recommendation on how to get around that. This particular set of rules has not been published. We're expecting it before summer. And just so you know, for reference sake, it is called 2019/904. That's going to be the implementing act for those rules. I just wanted to put on one last slide for you to say that another big change that was made in the Waste Framework Directive 2 years ago was on the extended producer responsibility part of the law. And they added an article called Article 8A, and it effectively sets out general requirements for extended producer responsibility. It was recommended by both industry and municipal government, so it was a sort of had full support. And it has some language in here, and I'll just pop these 3 pieces up that I extracted and pasted in the slide, just to show you language around third-party auditing, verified reporting, that EPR organizations must have adequate information on waste and data gathering, and that countries must establish adequate monitoring and enforcement. So you can see that there is quite a bit of new language requiring both producers in EPR organizations, but also member states to do a much better job on the data piece. So with that, I'm going to now move to our next speaker, and that's Joe Papineschi. And Joe and Reloop, Reloop has been working with Eunomia for many years. They do a lot of our content work for us. We work with Joe's team in England, but we also work with Sarah Edwards' team in America. And we were fortunate that Eunomia was hired by the Commission to do a lot of the background work leading up to the new calculation method. So who better to present this part than Joe Papineschi. So with that, I'm going to pass the mic to Joe. Joe?
Thanks a lot, Clarissa. So yeah, just very briefly on who we are. We're around 100 specialist circular economy consultants. As Clarissa said, we're based in Europe, but we've got a team in the States, and Sarah from that team, and also Andy from the UK are on the line, so they may well chip into the discussion after this presentation. And you can see we work across all of these sectors, so across the whole economy, the non-profits, supranational government, as we call it. So that's where the EU institutions and the Commission sits. The Commission is our biggest client, but it's actually, we have a very diverse range of clients, and we're working with national and state governments and municipalities, and lots of work for the private sector as well, including packaging producers, brand owners, and many of the raw materials companies as well. And what we try to do is to really apply as much as possible scientific rigor and a good kind of practical operational knowledge of how the real world works to this kind of policy project, which Clarissa's mentioned, which led to this new calculation method for recycling rates for Europe. And the background to that is that the EU, through these different directives, has had recycling targets for a long time. And this slightly crazy looking chart shows all of the member states and how they were performing against the 2020 recycling target for municipal waste of 50%. And you can see here that that's the red line in the middle, or the red circle in the middle is the countries that were below that level, and everyone kind of outside that on the teal line was above that level. But the slightly crazy thing about the system at the time was that there were 4 different methods you could choose to calculate your recycling rate. So we got to the point where there was, you know, not just no rules at all, there were 4 different choices that each country could make on which calculation method they used. And the EU ran a big program of supporting the lower performing countries, but actually the calculation method of those 4 that you chose was a huge factor in how you were performing. They were quite different to each other and generated quite different numbers based on the same activity on the ground. And so it was recognized that we really needed a consistent method for calculating recycling so they were comparable. But as Clarissa's explained, the political decision was to try to do that as far into the recycling process as possible. So obviously the trend historically has been that we want to collect recycling data, we want to use it to report performance and measure progress, but we want it to be motivating, and there's a tendency to calculate that the numerator in your recycling rate calculation quite soon after collection. And that's also where we've tended to have the best tonnage-based, actual weight data, where we're putting trucks over a weighbridge or whatever. And so what the EU decided it wanted to do was to shift that calculation point as close to the recycling process itself as it could. And so that's what most of what I'm going to talk about now is the numerator part of that calculation, and so how it works in practice. And I'm going to just recap a couple of the key points that Clarissa covered. So one is this definition of recycling, because as she's already explained, the idea was to calculate this numerator figure for each recycling process as close to the point where recycling is actually happening. And so a key part of that is this definition of recycling, and that includes certain things and excludes certain things. I've just highlighted a few things. Recovery operations are kind of everything from recovering energy to recovering materials, and that's very clearly defined in the law. But what this is saying is that recycling is a subset of those recovery operations. It applies to waste materials, so that is again very clearly specified in the law exactly what a waste is. And as this makes clear, it does include it basically includes anything reprocessed into a new product, material, or substance. Could be the same or a different purpose. It includes reprocessing of organic material through things like composting and anaerobic digestion, but it doesn't include energy recovery or the production of fuels or the preparation of material for backfilling operations, so things like restoring landfills, for instance. And so that gives us some clear inclusions and exclusions, and those get quite important with some parts of this in a moment. And then this point that, again, Clarissa explained, that we're trying to calculate at the point of entry into the recycling operation. And so we need to define what that is for different types of recycling processes, different materials. These rules apply for the calculation. We have, as again Clarissa showed us, two really key sets of targets the recycling industry and municipalities and producers are subject to. One is a set of targets for municipal waste, and the other is a set of targets for packaging waste. And broadly, the same rules apply to both. The same principles absolutely apply to both. But the kind of thinking has been done in a bit more detail with packaging, and I'm going to focus a little bit more on packaging. And to start with, just to kind of really explain how that principle works. You can see here these MPs are measurement points, and the idea of a measurement point is it's somewhere where you can actually measure the mass of the material at a point in a process. You can measure all of the mass of it. And so this is very generic, and you can see here we've got kind of a two-step pre-treatment process. So for example, sorting processes, and then we've got material going into an actual recycling operation at the end. And we're going to have losses at these different stages. And what we're able to do with these different measurement points is to weigh what's happening at those points, and to be able to use those to calculate those deductions reasonably accurately. And you can see here, basically, for instance, measurement point 3 is an output from that first process, and measurement point 4 is an input. Those two should be the same. There'll be few exceptions where those two numbers aren't the same number. And the general principle is that the calculation point is happening. It could be either measurement point 6 or 7, because generally they'll be the same number, but it's happening just before entry into that recycling operation. And the recycling operation may generate what are called inherent losses. So these are, things that we all understand, like loss of short fibers or inks in paper recycling processes, for instance. And we don't want to if we're calculating the recycling rate for instance, under the packaging rules, we have different targets for different materials. We don't want to kind of discriminate against materials based on the unavoidable losses that occur in the recycling operation itself. Obviously, what this is doing is taking us very close to the point where we actually start to get some benefit from all this recycling effort. But it's not taking us all the way there. That would be the other side of that recycling operation, where we actually have recycled content in a new product. So it's not quite taking us that far, but it's actually quite important to recognize that inherent losses vary by material and by process, and that we don't want to effectively have those distorting the targets that we might be setting for all of the actors before that stage, because we might be putting obligations on, let's say, municipalities or states or countries or producers for things that they can sort of control up to that point of entry into the recycling operation. So that was the logic for picking that calculation point. I'm just going to show you a few examples of what that means in practice for different materials. And so the one that gets a lot of attention is plastic, because we tended previously, and this is, you know, actually still very common in Europe, and this is all being implemented right now. So we're in this transition now, where we traditionally measured soon after the point of collection. So you might well be measuring your numerator in your recycling rate calculation based on baled material leaving a sorting facility, for instance. And as Clarissa's picture illustrated very clearly, there are significant losses after that stage in for instance, a plastic beverage package, or maybe even more so with a flexible package that's got a very low mass and, you know, a big surface area, so it might have quite a lot of residual product still sticking to it, for instance, and so all of that was being counted within the and still is, in fact, in you know, the most of the data gathering that's still happening was being counted within the numerator in that recycling rate calculation, and it was basically overstating the amount of material recycled versus this new calculation approach, which is trying to really measure the stuff that makes it all the way to the entry into the recycling operation. And so in practice, what we're talking about for a mechanical recycling process is the point at which there is no further pre-processing before extrusion, for instance. And this is, so typically that might be the washed flake stage in a process that's either going to go straight into a conversion process, a molding process of a product, or into a extrusion of new granulate. And there's some interesting issues with this. So, for instance, you could have a more thorough washing process for your flake. It could be a hot wash where you're going to probably have slightly higher losses, and that would mean that slightly less material would count in the denominator, in the numerator rather, than if you had a cold wash process, or if you didn't wash your flakes and you put them into a much cruder recycled product. So that's a potential slight issue with the calculation point as it's been set at the moment, but certainly from our understanding so far of what's happening, there's not a lot of incentive to kind of basically have a lower quality recycling process just in order to get that little bit of additional material to count within your numerator. So we don't think that's a significant risk. One thing that hasn't been addressed that clearly is the sort of whole range of what we call non-mechanical recycling processes. So as far as we have at the moment, there's some guidelines to member states that encourage the use of a mass balance approach, which makes sure it excludes anything which goes into a fuel or into recovery of energy within the process itself. So this is sort of broadly the categories of technologies that are classified as chemical recycling, although solvent purification is one which is technically not a chemical recycling process, but we kind of classify it as non-mechanical. And basically what you might have here are, in fact, solvent purification is one that kind of looks pretty similar to mechanical recycling. We don't think it's too complicated because you'll have losses from that pre-dissolving process that might go to energy recovery, for instance, but those will be quite measurable. So the recycling operation here, the earliest place it could possibly be is the dissolving process. And there's just some issues here around what happens to the waste solvents and any kind of contaminants that there might be in those wastes, and whether those should be kind of adjusted to make it equivalent to mechanical recycling. None of this is very sorted at the moment, but there's a research project going on at the moment to resolve this. Gets a little bit more complicated still with the kind of monomer recycling type processes you might see for polyesters, for instance, and where you have potentially more risk of consumption of material in the process itself. And then much more potentially complicated are the sort of thermal depolymerisation processes like pyrolysis and gasification, where there's a big debate at the moment around where the calculation point should be. Where is the recycling operation happening? Because there are potentially significant losses in these processes at various quite advanced points in the overall process, including losses to energy within the process and production of fuels. And so that part is still work in progress in Europe, although the mechanical recycling processes are much more resolved anyway as to exactly where the calculation point should be. And we're then into the rest of the packaging materials where things get quite a bit simpler. So paper, we're talking about basically entry into the pulper, and you will have some potential losses there of non-target material that makes it through the sorting process, but those are effectively allowed to be counted within the numerator as kind of natural losses of the paper recycling process, obviously along with things like short fibers. So things like windows on envelopes that you don't need to you don't need to adjust for those. And then the glass recycling process. This is again an interesting one because the principle is that you've basically finished all of the sorting and sort of preparation of that material that you're going to do. But obviously, for instance, glass going into graded aggregate is going to be probably still carrying more of those potential losses that you would have had to resolve before glass went into a remelt process, for instance. And a key thing to understand there is that depending on what those aggregates are used for, they may or may not count as recycling. So that's where you kind of have the check and balance there on glass recycling. And then the metals are pretty straightforward, where your calculation point is immediately before the smelting process. And then, with wooden packaging, so composting is allowed to be used for wood packaging fines, for instance, but broadly it's input into particle board production or into a composting facility. And there's lots of great reporting requirements to make all of these calculation processes work. We're actually employed by the Commission to both produce the guidelines for member states on operating this reporting process, and on supporting Eurostat, which is the part of the Commission which deals with this, in verifying the reports made by member states each year. There's a few other details that are worth just touching on briefly. One is that metals sorted from incinerator bottom ash do count. But for example, so something which some countries still count but won't be able to in future is, for instance, plastic packaging that goes into a cement kiln as an alternative fuel for cement production, and then ends up in clinker, or for instance, the aluminium layer that goes into composite packaging or foil that might go into a cement kiln, and actually that oxidizes and becomes useful aluminium oxide in the cement. That doesn't count. So it's only metals which are actually sorted from ash from a combustion process that can be counted. There's a slightly complicated issue with the way that composting has been legislated, and that's generating some confusing issues at the moment with member states trying to report on this for the first time, and that's because of this is actually in the law, so we're kind of stuck with it as it's drafted now. I've just underlined the key parts. So we're effectively allowed to count the amount where the treatment generates compost, digestate, or other outputs of a similar quantity to the recycled content in relation to input. That's fine, except that there are often other inputs, including moisture, which are difficult to adjust for. And then also this bit at the very end, where it only counts if this results in a product which benefits agricultural ecological improvement. That again is both quite difficult to really verify, and also sometimes you will have multiple outputs from a composting process. So how much of the output needs to be having that beneficial impact in order for that to count? So that again is slightly needs some further work before it's going to really work consistently between countries. Reuse is also important. So the targets apply to to recycling and to preparation for reuse. So there's quite a lot of work and guidelines on how you actually kind of calculate the difference between reuse itself, which would be a kind of peer-to-peer, someone else reusing something that someone else has discarded or doesn't want anymore. Whereas preparing for reuse might include, for instance, sorting textiles or refurbishing, washing machines or something like that. So there are sort of some quite clear guidelines for how that gets dealt with, and also actually for the denominator aspect of reusable packaging placed on the market, because obviously that gets to the end of its life eventually, but hopefully only after multiple reuse cycles. One of the key additional things which has been resolved is how we deal with composite packaging, or products made up of multiple materials. And now it used to be that they were just reported as the predominant material. So a beverage carton, an aseptic beverage carton, would be reported typically as paper. Now, if it has any component which is above 5% by mass, each of those materials has to be reported separately. And then another principle is that it's effectively the humidity of the material counted as it enters the recycling operation should be the same as, or equivalent to the humidity with which it was placed on the market. So effectively, you've got to adjust for any added moisture in, for instance, cardboard packaging, for instance. And then the last thing I wanted to cover, which is is this a transitional arrangement, or is this going to be required permanently? But this is a key kind of derogation that's allowed, where it's not possible or not practicable to actually get that weight-based information from the recycling industry. And obviously this is particularly likely to be the case where materials exported, where there's actually some additional requirements involving the kind of environmental regulators in those destination countries, but is often the case in existing recycling supply chains, particularly in the early stages of this implementation. It's still going to be common that there aren't contractual arrangements in place that require this data to flow back accurately up the stream, or there just aren't production processes that allow the accurate measurement of these tonnages going through the process. So there's this derogation allows member states to effectively report at an earlier stage, so after a sorting process, but maybe several steps before the recycling operation itself, provided that adjustments are made through these assumed average loss rates to account for the losses that would occur in those subsequent stages. And so this basically allows the system to work. It allows a complete data set to be produced. And so countries have to basically follow good process, scientifically robust sampling to aim to get as close as they can to what you would get if you could measure these flows at each step in the process in situations where that's not practicable. So that hopefully gives you, there's a huge amount more detail we could go into, but hopefully that gives you a good intro, a deep but not that deep dive.
Thank you so much, Joe, for that. That was a deep dive. And I think everybody, you can Google these rules. They are, you can type in the Google recycling calculation. It's 2019/665 or 2019/1004. So those are the two, and you can get all the language that I think can be very useful if you're in the process of writing rules yourself. I would highly recommend some cutting and pasting because it's, as I said, well vetted. So now I'd ask Susan if you could please load your presentation. And I'm going to introduce Susan Collins. Susan Collins is with the Container Recycling Institute, and they've been around for, I'm not even sure, 30 years, I think. But Susan and I have been working together for almost 15 years, collaborating on issues on many issues, particularly container deposit programs, but also on the issue of these loss rates. We've been talking about proper calculation method for years, and there is nobody that knows the average loss rates and the yield loss issue better than my friend Susan Collins. So Susan, are you ready to load your presentation?
I am. I'll press that button now. Thank you
Please
very
do.
much for that lovely introduction. Clarissa said I'm going to talk about what happens in the United States and give some specific examples that you can really visualize about where the losses occur, what types of losses there are that occur, what are they due to? A lot of it is due to the inherent makeup of the materials. And also, there have been a number of published reports. So I'm going to sort of flag those so that for people wanting to get a little more information on this, I'll be pointing you in the direction of places you can go to read even more about this subject. As an overarching statement at the beginning, I want to say that there's a big contrast here between the presentation that you've just seen about what's happening in the EU and what's happening in the US. In the US, no one is measuring on a consistent basis. There are no standards. There are no standards. And in some cases, there's transparency, and in some cases, there's not. So I'll point out what things are transparent and which aren't, and where the inconsistencies are. So we're going to start big picture. The total US recycling rate. These data are really old. It's literally, some of this stuff is from presentations that were as long as 10 years ago. That's how long we've been talking about this problem of the US recycling rate not having a good basis in fact and not being done on a mass balance basis. So way back when, we asked this question, is it 33% or 24%? And here's why. The US EPA has the method that they use to calculate the nation's recycling rate and calculate the nation's municipal solid waste generation. But other entities have independently calculated it, and all of the other independent entities that have done their own studies of how much municipal solid waste is generated, they've all come up with a much higher number. It appears that the US EPA is missing about 40% of what is generated. I will say that in the last couple of years, they've made some small improvements. So that 40% missing is maybe shrinking to like 38% missing. This slide shows the difference between the US EPA and Biocycle's method. Biocycle discontinued doing this process, so 2008 is the latest that we have, but the problem persists. And then here's what it looks like for diversion and recycling rates. The US EPA national diversion rate at that point was about 33%. It's hovered in that same range for the last 10 years. Whereas Biocycle's method, because Biocycle was capturing the full amount of material generated, the total recycling rate was only 24%. So obviously there's a lot of work to be done here, and on a big basis, what I'm talking about is more than 100 million tons that's missing from the method that the US EPA uses. So that's the national picture. Here's an example of one of the categories of material. The EPA method includes in-country glass bottle production data plus empty bottles imported, but we think they're missing a lot in that second category, plus full goods imported. So in theory, that would capture all of the material coming into the country, but the EPA method appears to omit secondary and tertiary packaging for imports. So that means that of that material coming in, they're only capturing the glass bottle. They're not capturing the cap, they're not capturing the box it comes in, they're not capturing the wooden pallet that it sits on, nor the shrink wrap and strapping that's holding all those boxes together on a pallet. When you think about this, this example is only for glass bottles, but when you think about all of the imported goods, all of our textiles and electronics and everything that's manufactured elsewhere that's imported, all of this secondary and tertiary packaging is missing from the US EPA calculation method. So moving away from that big picture of what's happening nationally at the US EPA level, we'll move into talking about curbside recycling for a few minutes here. In the average single stream collection program, if you collect 100 tons of recyclables at the curb on average, 75 tons will actually be recycled into new products, and most of the rest will be landfilled. This is what we found in a study that we released in 2012, a magazine article called A Common Theme. So I'm going to walk through how that happens. But want to emphasize what everyone on this meeting has said so far is that as we're having these policies and seeking to increase recycling rates, we need to report what is actually recycled, not just what is collected for recycling. And one of the implications of that, if there's some sort of ridiculous implications of doing this wrong, that if the recycling rates are reported without removing yield loss, it can lead to not only inflated recycling rates, but we're double counting material because material is being counted both as being recycled and sometimes it's being counted more than once as recycled. And then it's also being counted as disposed as well. So all of these stages lead to contamination and lead to losses. First, even in the collection stage, there's one material type I'll talk about in collection that, that actually has losses, significant losses at the collection stage. Then there's the MRF processing, when materials are sorted into the wrong bales, cross-contaminating each other. Then at post-MRF processing, more of the material is pulled out and some good material comes out with bad. And then eventually, hopefully, just the cleanest material goes on to stage 4 to be manufactured into new products. So while we're on this slide, I want to mention that even in the collection phase, especially here in the United States where we have single stream recycling and we're lifting up these carts and throwing them overhead and the material goes smashing down into the truck. I don't have data for this. Nobody that I know of has ever done a study on this, but I would estimate that we lose at least 10% of glass due to breakage at that phase where it's being either smashed by gravity into the collection truck or as the materials are compacted on the collection truck. Some of the glass will break, and at that moment it will be too small to ever be recovered in any process. So that's the first stage of loss, and it's really significant for glass. So we did take these losses all the way through the system and carry this out for beverage containers. We've got a study that we did, I think, in 2015, where we calculated the theoretical maximum for beverage containers. If everybody was doing everything exactly right, they were collecting 100% of their beverage containers that were generated at home and putting 100% of those containers in their curbside recycling bins, and if everybody actually had access to curbside recycling, we would still only ever get to 38% recycling for beverage containers. And that's because of all of these different stages of losses that we're going to talk about in this presentation. This slide and the next one are a summary of a study that was done in Oregon, and it was absolutely terrific. I love the concept of this study and I love the way they carried it out. They looked at every single bale and every bit of material moving through, I think 6 or 7 MRFs in the state of Oregon. And they not only looked at what was happening in the bale at the end, but they also looked at all of the residuals. So they looked at 100% of the material and they followed it all the way through, and they figured out that usually the way these studies are done is that you look at, let's say, a paper bale and you say, okay, 95% of the material in that paper bale is the correct material and the other 5% isn't correct. What they did differently in this study is that they went into meticulous detail about the material that isn't correct, so that they were able to determine for, let's say, all of the aluminum cans that are coming into the facility, not only how many aluminum cans ended up in the aluminum bale, but how many aluminum cans ended up in the PET bales, how many ended up in the paper bales, etc., so that they were able to trace the flow of all of the aluminum cans through the facility and do that for every single material type. So the contamination that we often hear about when people are talking about MRFs is that contamination makes up, in this case, 9 to 10% of incoming commingled or incoming material to the facility. But what they found in this study was also the additional cross-contamination in the bales. So here it is again, the same information in a flow chart. So we imagine if 100 tons come into the facility, about 10% is contaminants that never should have been there. That's in the gray box on the left. So that's going to go to the landfill. So then we move on. After we've taken out that 10% that should never be there, 90 tons is the proper material. But then because of cross-contamination, another 6.3 tons get sorted into the wrong bales. So when things are going out the back door, only 83.7, or we'll say 84%, is going to the correct facility. But then when it goes on to those correct facilities, the glass facility, the aluminum facility, blah, 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 they still have to filter out that additional contamination. They still have to filter out that 6.3 tons that was sorted incorrectly. So now I'm going to talk about the individual material types, and we'll start with glass. This picture is from a single glass beneficiation facility that I visited in California about 10 years ago. And the picture on the left is glass bottles that have been picked up from deposit programs. And the picture on the right is literally curbside glass. It doesn't look like glass at all. All you see there is mostly paper and a little bit of plastic. But that's because in transit, the glass sort of floats to the bottom of the pile and the paper sort of floats to the top of the pile. So the person who was giving me a tour of this facility did run his boot through the pile, and you could hear the glass in the pile. And I've since seen, more details of this. So I know there's a lot of glass in there, but about 40% of that material is not usable because it's paper and plastic and metal. This is a study that we did about 1.5 years ago, and it's on our website. It's a review of another study that was done in New York. But in order to do this, we wanted to illustrate where all of the material goes from the point it gets collected to the point it goes to a material recovery facility and then the glass processor and on to aggregate. And one of the things that we've learned only in the last few years is that a lot of the glass that was going into material recovery facilities around the United States, nobody ever even attempted to recycle that material. We don't even know how many MRFs that never even attempt to send it to a glass beneficiation facility. They either send glass directly to landfill, or they send it to aggregate, or they use it for alternative daily cover. And this is obviously not being published in a widespread way, or else the public would likely react and say, hey, I'm rinsing my glass bottles and putting them in my curbside bin. I expect them to be recycled. So it's hard data to get at because people are not being overt about these practices. But using this flow chart, I want to point out just 2 numbers here. The upper right, it says 37% recycled, sort of in red terracotta ink. That 117,000 tons. By the time that material makes it through the process and gets down to the bottom left, it's only about 38,000 tons because there are losses at every stage. And this is glass that's coming out of, coming through the curbside collection programs. So by contrast, here's the flow chart that we did for the deposit system for New York. If that material was put instead into New York, into the beverage container deposit program in New York, the picture would be different at both the front end and the back end. So way, way more material would be collected. You can see that on the upper right, it would be collection of about 205,000 tons. But because the losses are so much less all the way through the system, the total amount that would go into manufacturing down bottom left in blue, that blue arrow, almost 201,000 tons. So the gains when you're collecting material in the right way occur all the way through the process, and they really add up to a lot more. It seems like the whole is greater than the sum of its parts. This is another study that we did where we looked at glass collected for recycling in several different programs around the nation. And we even included some information from the EU and the UK. And the amount of glass that you're able to get as glass that can be utilized and actually be used in the manufacturing process is way, way, way higher if you have very, very clean collection processes at the front end. And this is not widely understood in the United States, not at all. I've got a few slides here now on PET bottle and jar recycling rates and what we know about yield losses and what we don't know. There is a report that is issued annually, or it was up until 2018, by 2 trade associations, NAPCOR and the Association for Post-Consumer Plastic Recycling. So we did have really good, pretty transparent data for many years, but they've stopped making that report public. So the data we have in here is a little old. We know that there's PET yield loss that's inherent to the container itself. You're going to have yield loss because of caps, labels, adhesives, base cups. There's also look-alike bottles that get put into the bale, and then there's other material types and thermoforms. And this is another one of those areas where it's really different if it's collected from a deposit program versus from curbside. One of the key things there is that curbside materials are going to have other kinds of bottles, like a soap dispenser that has a pump on the top. And a lot of times those pumps will have a metal part. And if all of that goes into a curbside bin and makes it into a PET bale, then you've suddenly got not just the different resin types that you're sorting out and the label, but then you've got a piece of metal that needs to be sorted out of the PET as well. This is what has happened over time when you compare PET recycling rates versus utilization rates. So this is really a measure of how much the contamination has increased over time. The farther and farther apart these two lines are, that difference is basically contamination or yield loss. So the recycling rate is the amount of material that is purchased by the reclaimers and they attempt to make it into flake or pellet. The utilization rate is what they're actually able to sell as usable material, as flake or as pellet. And you can see the widening between those two lines there. There's a tremendous amount of yield loss and contamination. This is what it looks like for deposit versus single stream. This is the latest available data from 2017. So deposit material, they actually have a utilization rate of 88% of that material, meaning they've lost 12% that they can never sell because it was either the wrong material type or it was filtered out. Single stream material, single stream curbside material has a much, much lower yield rate. It's only 68% instead of 88%. This is a study that was done in the state of California by CalRecycle, where they took apart bales very carefully and figured out what was in that PET bale. So there's a couple of things that I want to point out here. They were able to find losses of about 14%. You can see that they're showing here that PET bottles are 85.9%, but this is as it leaves the MRF. So what they don't capture in this information is the additional losses when the material is processed to take out the labels, to take out the caps, and the way you lose some good material along with the bad, because a lot of times the label and the PET material will be stuck together. And so you have to filter out the label because it's a different material type, and some of that good PET goes along with it. The other thing I want to point out about this is down in the lower right, we see an average there of 85.9%, but look at the difference between the min and the max. The min is 53.1% and the max is 95. That means out there's some really bad facility that's not trying very hard to clean up their PET material, and they only had 53% good material in the bale, whereas there was another really good facility that was producing really clean bales, and their bales were 95% clean material. So the variability is a big factor here. This is a more national study that was done by the Closed Loop partners just a couple of years ago, where they were looking at curbside PET bale composition. And so on average, what they were finding was a yield loss of 38%, which is pretty similar to what NAPCOR published at a yield loss of 32%. But I do want to point out one other thing, which is green flake. Some PET facilities have told me that they can't sell the green flake. So that ends up being a yield loss as well. It's shown as 5% here. I have a couple of slides here on aluminum making some of the same points. This was the study that was done by CalRecycle. You can see that they're showing losses of about 5% on aluminum. Aluminum tends to be the cleanest because it is positively sorted by eddy current separators. This is aluminum coming out of material recovery facilities in California. But then also look down at the lower right, the min and the max. So the difference between those two facilities is there's some facility out there that's only producing an 86% clean bale, and there's somebody else who's producing a 99% clean bale. So there's a lot of variability. On average, the research that we've done has shown that 11% is about what the losses are for aluminum. And that includes everything. That's including moisture loss and something that you don't get. Let me go back one. This aluminum bale composition is not going to capture the last stage of loss for aluminum, which is when the facility heats the container to burn off the outer paint and the inner plastic liner. So that's another loss that occurs to the weight for aluminum, and that's specific to aluminum. We have several studies that we've done over time that have touched on these topics, and they go into much more detail. And the very first one on here is one that Clarissa wrote all the way back in 2009. So we wanted to point out that these studies are available for you. They're on our website so that you can get more information on these. These last couple of slides I'm not going to go into. I sort of just included them as bonuses in the slide deck, but in the interest of time, I'm going to stop here, but just know that there's a couple more slides on paper yield losses as well. And with that, I'll turn it back over to Clarissa.
Thank you very much, Susan Collins. That was an extremely interesting presentation. And this marks the end of our recorded version of the webinar for today. We're going to continue now with a Q&A, but we're not recording it. If anybody that has watched this video has any further questions, please don't hesitate to contact me, Clarissa Morawski, or I'd be happy to put you in touch with our speakers. Thank you for joining us today. And once again, a huge thank you to our speakers, Joe Papineschi from Eunomia Research and Consulting, and Susan Collins from the Container Recycling Institute. We really, really appreciate your time today. Thanks, everybody, and goodbye from Reloop.